Greetings, dear students. This is Mathematics 4, also known as by its code BES MAT22. This is 2018 examination-based contact session. By that we mean it's meant to help you with your preparations for the upcoming examination. It takes a brief look at some of the topics that you experience problems with, especially in your assignment, and as such it should not be taken as a substitute for your study guide. Okay, so this, and it's also not a scope for your examination. It's really just looking at topics that we felt you experienced the most problems with in your assignments, and hence we feel that most students had or might have not grasped the concept of such topics, and therefore we are including it in this presentation. So you should still use your study guide as much as possible. You should read widely, using the supplementary materials that are mentioned in your study guides. Browse the internet. You might find some very useful materials on the internet that can help you with the topics that we are covering. So any textbook or ebook that carries topics that we are covering should be able to help you in one way or the other when studying for your examination. The important thing that you should, or that should guide you, is the learning outcomes at the beginning of each unit in your study guide. They tell you the skill and the knowledge that you should have, what you should be able to do after completing that study guide, after working through that unit. And if you find that by the end of the unit there are still some things in that list that you can't do, then you should seek for help. I should perhaps mention at this point that my number is right there on the title page, and therefore if there are any problems, arrangements can be made so that we solve that problem before you go into your exam hall. The first topic that we'll look at, first topic that most students experience problems with, was about direct and indirect proportions. Okay, the definitions that are given in your study guide, and we will try to restrict most of the definitions and explanations that we'll give to your study guides, unless there are some changes that we need to make, in which case we will say it. Two quantities are said to be directly proportional if, when one increases, then the other quantity will also increase, and when one decreases, then the other quantity will also decrease at the same rate. The rate is important. It's not just enough to say that if one increases, the other one increases, the one decreases, the other one decreases, but these are decreases at the same rate. And similarly, for an example, if you consider driving from here to Okahanja, okay, or some distance, or from wherever you are, you're going to pick up your kids or something, the fuel consumption, the rate at which your car consumes fuel, or the amount of fuel that your car uses, is directly proportional to the distance that you travel. The longer the distance, the higher the fuel consumption. You use more fuel if you travel a longer distance compared to if you travel a shorter distance. That's just an example, a very basic example of direct proportions, or two quantities that are directly proportional. Two quantities are said to be indirectly proportional, or sometimes also referred to as inversely proportional, if, when one quantity increases, the other decreases at the same rate. And when it decreases, the other one increases again at the same rate. So that's indirect proportion. A typical example is if you have a job that you want it done. If you want it to be done in the shortest possible time, you should hire more people. But if time is not really a problem for you, then you can hire one person and the guy will take as long as it takes. So it takes, or the time that it takes to do a job is inversely or indirectly proportional to the number of people that are doing that job. So the more the people, the shorter the time. So that's an example of indirect proportion. So and in your assignment, there were problems on direct proportion. There were also problems on indirect proportion. So most of you, for the direct proportion, I think that's straightforward. It's direct, so it's very straightforward for most of you. But I think the majority of you experience problems with the indirect proportion, and therefore we'll take a look at an example on the indirect or inverse proportion. Now, an example similar to the one that we had about a job and the number of people that are doing the job. Suppose that it takes 4 men 6 hours to repair a road. We read recently in the media that the Omakange or Poor Road had been washed away, and then suppose some guys were hired to repair that road. And it was realized that it takes 4 men 6 hours to repair a road. That's the analysis that was done. But of course, we want to repair this road in the shortest possible time. How long will it take 8 men to do the job if they work at the same rate? Okay. Now remember, this is an example of an inverse proportion. So the moment you find that the number of, you work something out and the number of hours increases as the men increase, then something is not right. It means you've worked out this problem the same way you would work out a direct proportion question. But that's not how it's supposed to be. It's supposed to be that if you increase the number of men, then the number of hours is supposed to decrease if these men are working at the same rate. And therefore, we have that if that is the case, if we call T the time it takes a man to do the job, then what we have is that 4 times 6 is supposed to be equal to 8 times T. Okay, and then you just make T the subjective formula, or you solve for T, and you will realize that it will only take 3 hours for 8 men to do this same job if they are working at the same rate. So you realize that from 4 to 8 men, the time has decreased from 6 to 3. Let's rephrase that. If you double the number of men doing the job, then time it takes, the number of hours has halved. So basically, the number of men has increased by a factor of 2, while the number of hours has decreased by a factor of 2. So the same rate that we are talking about is that if one increases, the other one decreases at the same rate. So that's what we have. So it takes 8 men only 3 hours to do the job. Now, the next problem that we also experienced problems with was, and most of us I think have this problem when it comes to money. Okay, you invest your money, and of course the bank or whatever financial institution that you are investing in gives you some options. We have simple interest, and then we have what is called the compound interest. Now, simple interest is simple because what you have is you have money is added, or interest is added on the original amount deposited with the bank or with the institution that you are investing in. So your interest is calculated on the original amount that you invested. If you deposit or invest $100, then interest will only be calculated on the $100. Now, so if P is the principal amount, so the money that you invest is called the principal amount, and then the bank gives you an interest rate of annual interest rate of say R, and this R is normally given as a percentage, which means I'll say will give you a 6% interest or 12% interest depending on how generous the bank is. And of course, T would be the investment period. This is normally in years. Of course, there are sometimes when people will give you an investment period of months, but in most cases it's in years. Then the simple interest is calculated using this formula, which means it's interest, which is R divided by 100, because remember R is given as a percentage. Percentage means that per 100. So you divide R by 100, and then you work out that R of P. Okay, that gives you the interest in 1 year or after 1 year. And then if you are investing for T years, then you need to multiply that annual interest, the interest that you will get in 1 year, by the number of years, so that you can get the total interest at the end of the investment period. This is probably a typo. It was probably supposed to be interest, not balance. It's not balance equals to PRT divided by 100, but rather interest equals to PRT divided by 100, because the balance would then be the sum of P and the interest that you invest. So at the end of the day, the total amount of money in your investment account will be the money that you put in plus the interest that you've earned over the T number of years. So just replace that balance with interest. So if we then take a very simple example, you invest 2,000 in an account for 3 years at an annual interest rate of 6%. Then the interest, the simple interest we will earn is given by P, which is 2,000, multiplied by R over 100, which means you'll have 6 over 100 will just be 0.06, and then you multiply this with 3. Okay, so in after 1 year, you will have P multiplied by 0.06. And then after 3 years, or to get the interest after 3 years, you multiply the interest after 1 year by the number of years, which is 3, and that will give you the simple interest. And in our case, the amount of interest that we will have earned after 3 years will be 360. So what does this mean about the total balance in our account after 3 years? Then after 3 years, we will have the money that we have invested plus the simple interest that we have earned after 3 years, which means it will be 2,000 plus 360, and that gives us 2,360 in our account after 3 years. So in 3 years, we would have earned 360 on top of our investment. That is simple interest. You work it out based on the original amount that you have invested. That's very straightforward. Now, then we have what is called the compound interest. Okay. Now, compound interest is interest earned on the principal amount and also on the interest. What does that mean? That means that by the end of the first year, for example, or your whatever your compounding period is, you add the interest earned to the original principal, and then you reinvest that money, which means in the second year, your interest will be calculated on the balance that you invested, as well as on the interest that you earned in the previous years. So that's what we have, that compound interest is the interest earned not only on the principal amount, but also on all interest that you earned in the previous years. So as we said, that's what you have. You earn interest, you add it to the original amount, and then you reinvest that money as well. Now, let's suppose, and of course, in this case, it's possible that the compounding is done more than once in a year. Okay, your bank might be generous and say we'll do the compounding, say twice in a year, or we'll do it 3 times or 4 times in a year, or we'll even do it monthly. Okay, so let's suppose that n is the number of times that the compounding is done per year. Then what you have is that if we suppose that they do it once, okay, then at the end of the first year, your balance after 1 year will be given by your P, okay, plus P means your principal, plus your PR over 100. Of course, your R, remember, is given as a percentage, and therefore we have to divide by 100. If we use 6% that we had in the previous example, then it will be 0.06. And of course, in the end, this will be P1 plus R over 100. Okay? And then what we have is that if we do it again for the second year, then in this case, what we do is we are investing or reinvesting B1, and it's no longer P. It will be B1, so we'll have B1 plus B1 R over 100. Okay? And this will give you B1, 1 plus R over 100. But then B1 is P1 plus R over 100. So in the end, you will get P 1 plus R over 100 to the power of 2. So if you continue this way, then your BT for a general time, number of years, you will get P 1 plus R over 100 to the power T. Okay? Good. Now suppose that instead of, this is when when N is equal to 1, you're compounding only once in a year. But if you're compounding N times in a year, then what you will have, if you follow the same reasoning, and of course you realize that your interest now, R over 100 is your interest annually. And therefore, at each compounding, you will have to divide that interest by the number of compoundings in a year, which means you will have BT. So for N, you will have BT is equal to P 1 plus R over 100, but then you divide this, at each compounding you divide this by N, the number of compoundings in a year. But then this you will have to do not only T times, but you do it T multiplied by N, which means the total number of compoundings in a year, which is N, multiplied by the number of years you will have Tn. So in the end, the balance at the end of T years is given by that formula. Okay, where remember your R is given as percentages. That's the reason for having the 100 there. But if you say your R has already been divided by 100, then you only have R over N all to the power 1 plus R over N all to the power of N over T. So that's what you have. So remember, R is given as a percentage in this case. So this is the formula for working out your balance. Not just the interest. This is the whole balance, because remember we said compound interest, you adding interest to your original and then you reinvesting and so on. You do it as many times as it's the number of years that you are investing. So that's what we have when it comes to compound interest. Right, now let's take a quick example. Okay, we have almost the same scenario, the same number of years, the same amount of money that we are investing, the same interest rate, but in this case we are compounding. So it's compound interest, not simple interest like it was in the previous example. But let's also assume that instead of compounding once in a year, we are compounding monthly. Compounding monthly means that we are compounding how many months in a year? 12. So we are compounding 12 times in a year. We get the following. The number of compounding, as we said, is 12, and therefore substituting this into our formula, P being 2000, T being 3, N being 12, and of course our R is 6. So we have 6 divided by 100. Then we get that. It's 2000 multiplied by 1 plus 6 over 100 times 12, all to the power of 12 times 3. So that's your Tn. And in the end, what you will get is 2,393.36 cents. Okay, so that's the amount of money that you get after 3 years. It's very important to note that there's a difference between your balance when you have simple compound and your balance when you have not simple compound but simple interest, and when you have compound interest. And it will even be different depending also on the number of compoundings that you do in a year. You can do more exercises on this, play around with it by changing the number of compoundings that you do in a year. You realize that the more compoundings you do in a year, the more money you will have in your account at the end of your investment period. So I just want you to compare this to the balance that we obtained with simple interest, and you realize that this one is more because your interest in subsequent years is calculated on not only the original amount that you invested, but also on the interest that you earned in the previous years. So that's what we have when it comes to simple interest versus compound interest, and the difference should be clear from your formulas. All right, so in the end, these are the important topics that you need to consider when it comes to your examination, in addition to the ones that we have already discussed, the examples that we have discussed. You should be able to rewrite numbers in their standard forms. Okay, if you're given a number, you should be able to rewrite these numbers in their standard forms. If you have problems with this, then please make sure that you study your study guide, then make sure you solve this problem. Don't be caught off guard. Make sure that you can rewrite numbers in their standard forms. And also, not just rewrite numbers in their standard forms, but also do some arithmetic with numbers in their standard forms without necessarily using your calculator. Personal income tax. you should be able to solve all the or most of the problems surrounding your personal income tax. Municipal services and tariffs. You don't let your municipality rob you, and do not let municipality rob your learners. You should be able to work it out for yourself. You should be able to explain this to your learners as well, how it works. How are the municipality billing you when it comes to your rates and taxes, when it comes to your water usage, and when it comes to your electricity usage as well. Of course, electricity is nowadays prepaid, but it does not hurt to also know how these things are worked out. Cash and hire purchase. Okay, the difference between buying something cash and buying something on a hire purchase basis. Okay, the accounts that we have in furniture shops, in Edgar's, and all these other shops, you should know that the difference between paying cash and hire purchase is that when it comes to the hire purchase, at the end of the day, the amount of money that you'll pay will be way more than what you would have paid had you just paid cash. Okay, so you should be able to solve problems regarding that. Surface areas and volumes. Okay, you're given a solid or a figure, you should be able to work out its surface area and its volumes as well. So make sure you know these things. Geometry. As I said, the learning outcomes when it comes to all these topics are listed at the beginnings of the units, and therefore they will tell you exactly what you need to be able to do when it comes to each of these topics, and the same goes for the geometry. It will tell you what you need to do when it comes to geometry. Finding angles and similar angles, complementary angles, and those types of things you should be able to do. And then we go to algebra. You need to be able to factorize an algebraic expression. You need to be able to simplify an algebraic expression, and you should be able to solve an algebraic equation and an algebraic inequality. Okay, differentiate between those two things: an equation and an inequality. An equation when you have an equal sign, and an inequality when you have an inequality sign, less than or equal to, greater than or equal to, and all those. So you should be able to know your ways around these things. Okay, simplification in most cases, factorizations and common factors and all these things, they all come together. So your learning outcomes when it comes to the algebra units should guide you in the type of things that you need to be able to do. And as I said, do as many exercises as possible. And in conclusion, as I said in the beginning, we cover some topics, not all, so this is not a scope. It's really just a presentation meant to help you with problems that you experience in your assignment, and not all. We're taking common mistakes. There might be individuals in your group who experience some problems that were not covered here, in which case, as I said, at the cover page, my phone number is there, and on a one-to-one basis that can be solved. And of course, we hope that after this presentation, you're not going to have these problems coming into or going into your examination. We hope that it will solve them. And as I said, we would like to emphasize that this presentation does not substitute your study guide. When you are preparing for your examination, read as widely as possible your study guide, resources, supplementary resources that are listed in your study guide, as well as e-resources, e-books, internet, websites that can help you with these types of things. And you could also look, I think there's a channel on DSTV that normally looks at some mathematics and other subjects problems that students experience. So you might not have to just look it up and do as many exercises as possible, please. Solve problems so that you familiarize yourselves with solving these types of problems. You're not going to have so much time to scratch your heads and bite your pen in examination. You should be able to know what to do when you get certain problems. I wish you all the best with your examinations and good luck.